Well, an aircraft has to displace its displacement of air volume at a fast enough speed for its friction on the wings to keep the aircraft up. And of course, an aircraft has to gain a certain altitude to begin with anyway, which uses energy as well. The Bernoulli effect. Whereas a ship only has to move the displacement of the water that it takes up over the distance that it wishes to travel. And if it does this at a slowish speed, say 25 knots, then the friction is very small. And there is, of course, no need for speed to keep the ship buoyant, nor is there any need to gain the altitude. Of course, the journey is much longer in time duration than flying. Compare this now to a Zeppelin, an air balloon. Well, it's got to displace a mass of air equal to its volume in order to move from one place to another. That might be quite large because the balloon itself is large, and of course it depends on the density of the content of the balloon as regards friction, but of course the hot air balloon's not going to be moving very fast. Sorry, not hot air balloon, Zeppelin, gas balloon. However, it's more variable according to wind speed. Being of large volume with, say, a headwind. And of course could actually be flying backwards, not forwards, in effect, as regards the ground, where the wind is more powerful than we'd probably use a jet to drive it these days. But propellers in historical sense. Interesting comparison would be, wouldn't it? To keep one's bearings, it's as well to remember that in space, assuming you've escaped the gravitational force, which you have to do first, of course, to get off the planet, but assuming you're in space, to increase speed, to accelerate, you expend energy, but once you're up to the speed you want, well, theoretically there's nothing in your way from then on, so you continue at that speed at zero extra energy cost indefinitely. In fact, of course, space is not empty, and you do come to a standstill in the end. In part because you're moving extremely sparse matter out of the way as you go. The space is basically empty. Well, I'm not sure if there isn't some theory that because the universe is expanding, I don't know, there's something about you end up at zero speed relative to the expansion of the universe at some point. That in some sense the expansion of the universe given time extension overcomes the speed at which you've accelerated to. Don't really see why that would be so. Not sure at all. Thank you, Heavenly Dad. I don't need to know, so I mean, I was just interested by the phenomena possible. Thank you, Heavenly Dad. I was reminded listening to this that the Armada, as it moved westward over the top of northern Scotland, misjudged how far west it had gone because the current was actually against it. And, you know, in some sense, the current could actually be greater than your directional speed that you're interested in. And so you're actually moving backwards relative to the fixed earth underneath you, so to speak. In each case, each scenario we think of, it's never the pure case. We've simplified it. You know, I mean, is one going to take into account the expansion of space? Is one going to take into account the current moving against you relative to the land under you? How many things are you going to take? You know, are you moving relative to the water or to the land? Are you moving relative to some objects in space, treating them as fixed? Or are you assuming that they're also shifting, and relative to what? Are you assuming you're beyond gravitational fields? Or is in fact everybody in the universe, to some extent, putting a gravitational field on you, although it's absurdly distant away? There's an absurdly small tug in that direction. It's the trouble with theorizing. We simplify things to sort of handle rough and ready solutions, and then we get upset because the rough and ready solutions are too rough and ready. Well, not too ready, but too rough. And so we have to refine our models and our theories, and, you know, we move on to the next level of generalization, or you could say slightly less generalization than before. There are too many variables. The entire universe is interrelated. To have a model of the universe that was exact, I think you'd have to have a parallel universe. And you'd be no more the wiser, because it's still too complicated for you to understand. Thank you, Heavenly Dad. I see motion as a most unusual phenomenon, because it spans time. And we don't know why one time should affect the next, especially when we consider motion, which is a shift in location from one time to the next. Why should the past motion affect the present into the future motion? You don't know, it just does. A bit like gravity. We want to always explain things in terms of something else. But the universe may be a plurality of non-related phenomena. Causally independent from the point of view of input, but in the mix causing an amazing interrelationship. It's not clear that you can reason from the mix back to what the individual input is. So we're looking at the confusion of both time and motion. And physical phenomena compared to the thought of phenomena that we have. We're dealing with that thought of phenomena as if it were physical. We conceptualize it in a sense as an object or an input. But these inputs may just be independent beings. I don't know. I say that's the one thing we're clear on, is that we do not know. You know, Einstein grapples with what gravity is and what time is, and comes to the conclusion that light has a finite maximum speed, but seems to have lost the realization that the speed is relative, so that, you know, if light is travelling at speed of light in one direction, or say 3/4 of the speed of light that it could travel at in some completely empty medium, or could it travel at all if the medium were completely empty? Does light in fact travel, or simply appear to? Well, I was going to say, if it's travelling at the speed of 3/4 the speed of light in one direction, and the light from another star's shining 3/4 the speed of light in the other direction, and clearly they're passing each other at more than the speed of light, the two light beams. Not only that, but they don't seem to interfere with each other when they pass through each other, which means light may be itself simply extremely sparse moving matter, but to be moving at such speed honestly doesn't make much acceptable sense to us. Light may more be a state of being, as when the light appears to come on into a room, it doesn't seem to emanate, because we don't have the time sensitivity to see it moving from the light bulb into the darkness at the moment you flick the light on. It's just that the whole darkness seems to change to light. You could say there's still a time dimension in there, it's just that it's so immediate that you take it to be immediate, instant. When we theorize that it can't be. And perhaps we demonstrate such too. We don't know what light is. Not really, and we can't therefore reliably conclude what its features are in terms of other phenomena like time and speed and relocation and so forth. It's a bit like electricity, where we thought that the electrons were moving in the wire, or we've simplified it to that sort of model, whereas the power seems to be a force field round the wire, and hence this can be continuous even though the wire isn't. You know, we say, oh, the electrons have jumped the gap. Well, but they were in the outer hemisphere of the wire all the time. Not in the wire at all. It doesn't make sense, no, it doesn't make sense to me either. Well, I mean, I can imagine it, but not at all clear on the reality of such, or what it means. But there's many phenomena like this. I mean, thoughts. Are they latently stored in some physical phenomena, like some configuration of nerve cells and so on? Or is it something else, in dimensions that we're not au fait with in our primitive, basic handling of matter and motion and temperature, energy, and so forth? That these are really just the crude simplifications of an interrelation of, or matrix of a phenomena that we can't at present conceive of, imagine, and certainly measure and quantify. So we can share the same thought, but it doesn't get thinner, although it does become more varied, more confused with, if you like, misunderstanding between each other in the communication. But we go away with a different state, having talked with each other, than before we came, before we met. In particular, I'm fascinated by how thoughts come into mind. Now that suggests, of course, it's outside source, that way of putting it. Another way of putting it might have been how we in the mind generate thoughts or retrieve them from a store within the mind. But searching out the matrix and recognizing it in the mind is rather more difficult. We sort of feel it must be in there in something to do with the neurons, something to do with their structure or charge or disposition in some way that changes with different thoughts. But it's beyond our thoughts, really, beyond our grasp. Thank you, Heavenly Dad.